Hello there, my name is Noah Geiger, and welcome to the final lab for Physics 2, Magnetic Braking. Let's get to it. Purpose for this lab is to collect data on how much time it takes for a magnet to fall while inside an aluminum-wrapped tube, demonstrated by the induced current of Faraday's law. Our results here in our experiment, we had 1.24 seconds. Our computational was 1.19. Important topics we're going to be using is Faraday's law, Lenz's law, Biot-Savart's law, and Newton's second law. So basically, we're going to be incorporating all the magnetic laws that we have been using in the past, as well as use a little bit of gravity to kind of explain the phenomenon we see and why the magnet slows down as it falls down the tube. As you can see, here's our data: length, width, inner radius, outer radius, all that jazz. And those are the trials that we did, and we came out with again an average of 1.24, which is quite funny. Um, just because you would think it would fall faster than what it did, but you could actually just see it falling slowly, and that's because of Faraday's law. Here's some of the code. Yeah. So calculations here are for one to calculate the speed it's going down, and it's going to incorporate um the magnetic stuff from the aluminum. That's going to be Lenz's law, trying to bring back to equilibrium, as well as the forces of gravity trying to bring it down. So this code is trying to incorporate all that stuff into it. Here's our model. As you can see, the blue started from the top and went all the way down slowly, slowly. And here's the graph of the velocity. So it was a sharply, and then came back to steadied out, and then once it got to the bottom there where the aluminum tubing wasn't, it fell down. But you can kind of see this nice constant thing, and that to model the breaking of the aluminum sheet of the aluminum tube. So what if the resistivity of the conductor were reduced as close as possible to zero? How would the dynamics of the falling magnet change? Um, it probably would fall a little bit slower. Resistance makes stuff work worse. That's kind of the best way I can explain it. So basically, is asking what if there was perfect conditions, and I would say it would most likely fall slower. Uh, Holes or slots were cut into the tube. How would this affect the ring currents in your model? This is a bit kind of a wacky question, but I'm gonna assume it means like throughout the thing. I'm gonna say it would actually make it speeded up, just because if it disrupts the current generated, if it's not consistent, then we can go back to that graph. Then it'll be all funky. But overall, it might still slow it down, but only minimally. Thank you guys. Some margin of errors here, of course, would be uh how fast you click the button because we were hand measuring it, as well as the aluminum, being used, old, crinkly. It might have been better to use, different types of aluminum, that could have worked, impurities in the aluminum. And like this was saying, there's some resistance in there, so those are possible things right there. Thank you, and hope you have a good day.